The properties of set operations are as follows. The first one is commutative property, and next we have associative property. So initially, let us discuss about the commutative property. So what do we mean by commutative property? Let us take any two sets A and B. Then the commutative property states that union of two sets is commutative. So basically, if you do A union B or B union A, the answers are going to be equal. Likewise, the intersection of two sets is also commutative, they are saying. Basically, which means if you do A intersection B and B intersection A, they both of them will be equal to each other. Now let us prove this with the help of an example, right? So what is the given question? If A consists of element B, E, G and F and B consists of element C, E, G and H, then we have to verify the commutative property of union of sets and intersection of sets. Alright, so let us first prove the union of sets. How do we prove? Let us write the given question. Next, we have to find A union B. How do we find A union B? You have to write all the elements without any repetition. So all the elements are written down over here without any repetition. Now let us mark this as equation 1. Next, we have to find B union A. Again, you'll get the same element with, and you have to write it without any repetition, right? And then mark it as equation 2. Now, carefully observe both the equation 1 and equation 2. Do you find any changes over there? No, right? Both are same, right? So we have proved that A union B equals to B union A, which means union of sets is commutative. Next, let us prove that intersection of sets is also commutative with the same example. So this is given to me. A and B, these are the two sets given to me. Now let me find the intersection of them. Intersection means the elements which are common between both the sets. So if you see carefully, you'll be able to see the only elements which are common between the set A and B is E and G, right? Let us mark this as equation 3. Next we have to find B intersection A. Again, if you see in B intersection A, you have only two elements which are common, that is E and G. Therefore, mark this as equation 4. Again, carefully observe equation 3 and equation 4. What do you get? Both are equal, right? Hence, we have proved that intersection of sets is also commutative. Next, this is very important, students. Set difference is not commutative. Now, let us first get back to what is set difference. I hope you remember in previous class we have studied about set difference, right? So, we have studied that A minus B, which means X belongs to A and X does not belongs to B. Likewise, B minus A means Y belongs to B and Y does not belongs to A. Let us understand this better with the help of an example. This is the given question. If A and B be any two sets, we have to find A minus B and then B minus A. So let's find the first subdivision A minus B. How do we find A minus B? Let me write A and B over here. A minus B means the elements of B which are there in A has to be eliminated. Now if you see the elements of B which are there in A are 1 and 4. So we have taken down 1 and 4. So you have to write the left out elements of A alone. So the left out elements of A are minus 3 and minus 2, right? Next, we have to find B minus A. So what do we mean by B minus A? The elements of A which are there in B are supposed to be eliminated. So what are the elements of A which are there in B? 1 and 4, right? So we have to remove 1 and 4 from B. So you have to write the left out elements. The left out elements are 0 and 2. Now please observe the solution of A minus B and B minus A. Are they both equal to each other? Definitely no. So we have proved that the set difference is not commutative, right? All right. Next, let's move on to next property, which is called as associative property. So, what is the difference between commutative property and associative property is commutative property deals with two sets, whereas associative property deals with three sets, namely A, B, and C. So, again, in this case, we are trying to say that union of three sets are associative. Likewise, intersection of three sets is also associative. Now, we shall prove this with the help of an example. So, we have this example. Let A be A and T, and B consist of element T, A, and P, and C consist of element S, A, and P. You have to prove that A union B union C equals to A union B union C. Now let us take the LHS first, which means the left hand side. So what is my left hand side? A union B union C. So you're supposed to first solve the one which is in the bracket. So if you see carefully, the one which is in the bracket is A union B. Let us find A union B, which means I have to write the all the elements without any repetition. So these are the elements. Next, I have to find A union B union C. So I have written down my A union B, which I have just found, and then I have also written the union symbol, and I have also written the set C, right? Now I have to find the union of them. Then let's move on to RHS. What does my RHS says? I have to find A union B union C. Again, even in this case, the one which is there in the bracket first has to be solved. So let us first find B union C. If you find B union C, what do you get? You get these elements, right? Yes. And then you're supposed to do this with A. You have to find the union of this with A. So I have written down my set A over here. I have also written down my B union C, which I have just found, right? And then I have got this as the answer, which means I have to write all the elements but without any repetition. Yes, I have written. Now carefully observe both these answers. What do you get? Both the solutions are equal to each other, right? So LHS is equal to RHS, which means my union of three sets is also associative, right? Next we shall prove that intersection of three sets is also associative with the help of an example. So these are the given sets to me, A, B, and C. We have to prove that intersection of these sets are associative. Let us start doing it as we have done in the previous sum. LHS part first. So what is my LHS? A intersection B intersection C. I have to first solve the one which is in the bracket. So A intersection B is in the bracket. So I have to find the intersection of A and B. What do we mean by intersection? Intersection means the elements which are common between them, right? So if you see carefully, the elements common between them are A and T, right? So I have written down A and T. Now I have to do the intersection of this with C, right? So what will I get? Again, the common element. If you see carefully, what is common between them? Only element A, right? I have written down. Next, let's move on to RHS part. Again, in RHS part, the one which is there in the bracket has to be solved first. So B intersection C is there in the bracket. I'm supposed to find the intersection of B and C. If you see carefully, you will see there are only two elements which are common between B and C, which is A and P. I have written it down. Right now, I have to do the intersection of this with A. So if I do the intersection of this with A, what will I get back? Again, I'll get back my element A. So if you see carefully, my LHS part is equal to my RHS part. Yes. So I have also proved that intersection of the three sets are also associative. Right, students? So this is very important. This is identity property for union. So what do we mean by identity property for union? Identity property of union says that the union of a set and the empty set is the set itself, it seems. So let's try to understand this better with the help of an example. But before proceeding to that, the general property is very important, students. A union, the null set or null set union A is again A itself, where A is any set. I hope you can understand, but let's try to understand this better with the help of an example. So what is given to me? Example, let A be a set which consists of elements 3, 7 and 11, and B be a set such that X is a natural number less than 0. If you see, is X natural number less than 0, natural numbers itself starts from 1. So there is not possible of any natural number which is less than 0, right? So B is a null set. Now let us find the union of these both. So what do I get? A union B, I get back my A itself, right students? So we have proved that A union null set or null set union A will give you back my A itself, where A be a any set. Yes? Next we have intersection property of empty set. What does it states? It states that any set intersected with the empty set gives you the empty set itself, it seems so, which means if you do the intersection of A, where let A be any set, so A intersection the null set or null set intersection A will give you back the null set itself, it seems. Now let us try to understand this better with the help of an example. So my example is, let A belongs to 3, 7 and 11 and B be X such that X is a natural number less than 0. Again, if you see, there is no natural number which is less than 0, right? So my B is a null set. I have to do the intersection of them. What do we mean by intersection? The elements which are common between both the sets. If you see carefully, there are no elements which are common between both the sets, right? So you have to write the null set back. So I have proved my general property which says that A intersection null set or null set intersection A will give you back your null set itself. Now let's move on to exercise sums. Exercise 1.4. First sum, second subdivision. So if P, Q, R and S are the given sets, we have to find P intersection Q intersection S, it seems. Okay, so how do we find it? As I told you, we have to first solve the one which is given in the bracket. If you see carefully, what is given in the bracket? P intersection Q is given to you in the bracket, right? We have to first find the P intersection Q. Okay, so let me write my P and Q. Yes, I have written. Now, if you see carefully, what are the elements which are common between them? 2, 5 and 9, right? These are the only elements which are common between P and Q. Now I have to find the intersection of this with S. So I have written down my P intersection Q, which I just found, and then I have also written down my set S. Yes. So again, what do I get? The elements which are common between these both are 2 and 5 alone. Right, students? Now let's move on to the next question. So question number 2, we have to test the commutative property of union and intersection of these two sets, it seems. Okay, P and Q are given to me. X is a natural number between 2 and 7 and X is an irrational number between 2 and 7. Alright, before getting into the sum, let us first of all write the definition of commutative property of union of sets. So what is the definition of commutative property of union of sets? It is A union B is equals to B union A. All right. Now the given set P and Q, let us rewrite this in the roster form. If we rewrite this, what do we get? They have given us that X is a real number between 2 and 7. So between means 2 and 7 are not included. So what comes between 2 and 7? 3, 4, 5 and 6. Please make a note, students, 2 and 7 will not be included because they have given between over here. If this between was not there, you could easily include 2 and 7. All right, next you have Q is equal to X such that X is an irrational number between 2 and 7. All right, irrational number. What do we mean by irrational number? irrational numbers are numbers with square roots, right? So what are the numbers which will come between 2 and 7? If you see roots, it is root 3, root 4, root 5 and root 6, right? But then if you see carefully, do you think that root 4 is an irrational number? Absolutely no, right? Why? Because root 4 is equals to 2, correct? So 2 is not a irrational number, whereas 2 is a rational number. So I cannot include root 4 over here. So the left out elements to be included in Q are root 3, root 5 and root 6. Now let's get back to the sum. What commutative property means, I have to first find the union of P and Q, and then I have to find the union of Q and P, and then prove them to be equal. So let's first find the union of P and Q. I have written down my set P and Q. I have to find the union of them. So what do I get? I have to write all the elements without any repetition. All right. And then I have to mark this as equation 1. Next, I have to find Q union P. Q I have written down first, and then I have written down P. Next, I have to do the union of them. If I do the union of them, what do I get? I get all the elements but without any repetition. Let me mark this as equation 2. Now, if you see carefully, you will be able to see that equation 1 and equation 2 are equal to each other, right? Which means that union of sets is commutative. We have proved it, right? Yes, students. Next, we also have to find the intersection of sets, right? Commutative, we have to also prove the commutative property of intersection of sets. So again, what is my formula? The same formula applies over here as well. So which means P intersection Q is equals to Q intersection P. Let me first find my P intersection Q. What is my P intersection Q? I have to write the set P and then set Q over here. So do you find anything common between them? No, right? You cannot say 3 and root 3 are common. Be very careful, students. Likewise, root 5 and root 5 are also not equal to each other. They both are completely different. So there is nothing common between them. So I have written down as a empty set or a null set, and then I have marked it as equation 1, right? Then I have to also find Q intersection P. What is my Q intersection P? I have to write Q first and then P. Again, if you see, is there anything common between them? No. So what do I get? I get my null set. Let me mark this as equation 2. Now if you see carefully from equation 1 and equation 2, you'll be able to find that these both are equal to each other. So we have proved that P intersection Q is equals to Q intersection P, right? Now let's move on to the next sum, question number 5. So what do I have my question number 5 as? If A equals to X such that X is equals to 2 power N, where N belongs to whole number and N is less than 4. And B equals to X such that X is equals to 2N and N belongs to natural number and N is less than or equal to 4, and C is given to me as 0, 1, 2, 5 and 6. Alright. So I have to verify the associative property of intersection of sets. Alright. So let us first find the set A and B in the roster form. Before proceeding, what they have given X is equal to 2 power N. They have also told us that this N belongs to a whole number and this N is less than 4, it seems. Now, N belongs to whole number means it starts from 0. And where does, as in it ends before 4, right? Why? Because there is no equal to symbol over here. So my 4 is not included. So it ends before 4, right? So what is my small n stands for? It stands for 0, 1, 2 and 3. So I have to substitute n as 0, 1, 2 and 3. After substituting, I get these answers, right? 2 power 0. Anything to the power 0 is 1, not just 2 power 0, students. So anything to the power of 0 is 1. I get it. So again, 2 power 1 is 2, 2 power 2 is 4, 2 cube is 8. I have got my A in the roster form. These are the elements of A. Next, let us find B in the similar manner, right? So, what do I have my B? B is x such that x is equal to 2n, and again this small n belongs to a natural number and this small n is less than or equal to 4, it seems. So, tell me, from the natural number starts from which? It starts from 1, right? So, it starts from 1 and it ends up to 4. 4 is included over here. Why? What is the difference? If you see very carefully, there is no less equal to symbol over here, whereas we have equal to symbol over here, which means 4 is also included. So in the place of n, I'm supposed to write 1, 2, 3, and 4. I have to simply multiply this. I have to substitute in the place of n 1, 2, 3, and 4, and then I'll get back these answers. 2 into 1 is 2, 2 into 2 is 4, 2 into 3 is 6, 2 and 4 is 8. So this is my set B. 2, 4, 6 and 8 I have got. C is already given to me. Now let us proceed with associative property of intersection of sets. First of all, let us write the definition of associative property of intersection of sets. This is a definition of intersection of associative property of intersection of sets. It is A intersection B intersection C equals to A intersection B intersection C. All right. So I have to write my LHS first. So LHS, what do we have? We have to first solve the one which is there in the bracket. What is there in the bracket? B intersection C is there in the bracket, right? So let us first find B intersection C. What do we get? If you do the intersection of them, you get two elements which are common, that is 2 and 6. Then you have to also find the intersection of this with A. Let me write my set A. I have written on my set A. I have also written on B intersection C, right? So what are the elements in common between them? Only one element, which is 2, right? Let us mark this as equation 1. Now let us move on to the RHS part. What does my RHS says? A intersection B intersection C, it seems. So I have to first solve the one which is there in the bracket, right? So let me first find A intersection B. So after finding A intersection B, what do I get? I get the ones which are common between them. What is common between them? 2, 4 and 8 is common between them, right? Then I have to find the intersection of this with element C, set C. So I get again 2 as the answer, right? Only the element 2 is common between them. So we have proof from equation 1 and 2 that the associative property of intersection of sets, right? We have proved that intersection of sets are also associative, right, students? So the homework questions will be given to you all through Google Classroom. All right, students. So let's do a quick recap as to whatever we have studied in today's class. So we studied about the different properties of set operations. As you know that there are two properties. One is commutative and then associative. So this is the definition of commutative property for union of sets, and this is the definition for intersection of sets. So for union it is A union B equals to B union A, and for intersection it is A intersection B equals to B intersection A, right? And as I told you that this is very important, we have to know that the set difference is not commutative. Basically, A difference B is not equal to B difference A, which means A minus B is not equal to B minus A, right? Next, moving on to associative property. This is the associative property for union of sets, and this is the intersection for associative property, right? So for union, we have A union B union C equals to A union B union C. And for intersection, we have A intersection B intersection C equals to A intersection B intersection C, right? And this is the identity property for union, which states that let A be any set. So A union, the null set will be equal to A, or null set union A will also be equal to A itself. Next, we studied about the intersection property of empty set, which states that A intersection null set or null set intersection A will give me back my null set itself, right? And you should also note that the set difference is also not associative. All right, students, thank you so much.